Hello everyone, welcome to the session. I am Shravani. Today I was going to discuss about 5 molecular orbitals of butadiene and benzene. Before going to this, we should know little about formation of 5 molecular orbitals and their interactions. So coming to the 5 molecular orbitals, these are formed by the combination of p atomic orbitals. So within this diagram, I have shown you clearly. So coming to the p orbital, atomic orbital. So p, as we all know that the shape of p orbital is dumbbell in shape. So it is having two lobes, one lobe with positive sign and the other lobe with negative sign. We can observe bonding interactions between two p atomic orbitals when the orbitals line up in a way that each lobe overlap another p orbital having the same signs. That means, so here one p orbit, when two p or atomic orbitals approach each other which are having the same sign. So here this p atomic orbital is with positive sign and this one is also with positive sign. Similarly here with negative sign and here also with negative sign. So when two p atomic orbitals line up in this manner, they are going to show in phase combination and results in the formation of bonding molecular orbitals. So the another way of combination is when two p atomic orbitals with opposite signs. Okay, so this one with this lobe with positive and this lobe with negative, both are with opposite. So when two p atomic orbitals approach each other with opposite sign, there will be a formation of node like this. Where there is a formation of node, we cannot find the position of electron. So here we are going to observe zero electron density due to the formation of the node. Here, due to the formation of the node in between these two atomic orbitals, we are going to observe anti-bonding interactions. So when two p atomic orbitals approach each other, they results in the formation of two molecular orbitals. One is bonding molecular orbital, this one, and the other one is anti-bonding molecular orbital. This is the anti-bonding molecular orbital. So I repeat once again. So molecular orbitals formed by the combination of two p atomic orbitals. When two p atomic orbitals which are having the same sign approach each other, they are going to show in phase overlapping, which results in the formation of bonding molecular orbital. The other way is when two p atomic orbitals approach each other with opposite sign. Due to the formation of the node, we cannot locate the position of electron because of zero electron density. So these two are going to show anti-bonding interactions. Hence these are anti-bonding molecular orbitals. Next, moving to the next one. So if we understand this clearly, we can study clearly about the 5 molecular orbitals of butadiene. So coming to the butadiene, first look at the structure. So buta means presence of 4 carbons. So within this structure, we can clearly see 4 carbon atoms here. So next one is diene. So di indicates presence of 2, and ene in alkane means single bond and alkane means double bond and alkynes means triple bond. So within the name here they had given diene. So that indicates presence of 2 double bonds. So here one more thing we have to notice, that is all the double bonds are in conjugation. So when we observe the structure of 1,3 butadiene, it consists of 2 conjugated double bonds. So that means the structure has 4 sp2 hybridized carbon atoms. Each atom is going to contribute a p atomic orbital which is having 1 electron each. So this carbon, so coming to the here we are going to observe the double bonds, and these double bonds contains 4. We are going to see 2 double bonds within the structure. So that means 4 electrons. These 4 electrons we won't be here at one time. They will go on resonance which to attain the stability. So to increase the stability of the molecule. So due to the resonance, this molecule, and due to the presence of conjugated double bonds, this molecule is highly stable. So coming to the next one, as I already mentioned, it is built up of 4 sp2 hybridized carbon atom, and each p orbital is associated with 1 electron each. The other method is for building the pi molecular orbitals of butadiene is by the combination of pi molecular orbitals of two ethene molecules also. So here we are going to observe these 4 carbon atoms. That means these 4 p orbitals which are associated with 1 electron each are going to form the bonding molecular orbitals and antibonding molecular orbitals. Let us see within this diagram bonding and antibonding interactions clearly. So this is the this arrow mark indicates the increasing energy. Okay. So next, coming to this, these are the 4 p atomic orbitals. Now these 4 p atomic orbitals overlap each other and results in the formation of 4 molecular orbitals. Out of those 4 molecular orbitals, 2 are bonding molecular orbitals and 2 are anti-bonding molecular orbitals. How we can locate that? So within this energy increase, we can observe one center line. So this line is known as non-bonding line. Here we cannot see any kind of overlapping because here the vibrations are purely zero, and the orbitals which are below this line, that means these two orbitals are known as bonding molecular orbitals, and above this line, this is the center non-bonding line. Here vibrations are purely zero, hence we cannot observe any kind of overlapping here. So coming to the above the line, we are going to observe another combination, that is anti-bonding molecular orbitals. Now, first we should give the name. So these 4p atomic orbitals will overlap each other and results in the formation of bonding molecular orbitals and anti-bonding molecular orbitals. So out of these, so first energy level is named with Xi1, and second one with Xi2, and third one with Xi3, and the fourth one is Xi4. These are the energy levels. So coming to now, we have to distribute the nodes. Okay, so nodes within the case of Xi1 energy level, the number of nodes are 0. That means within the case of Xi1 energy level, when we are going to observe the interactions here, the combination is completely in phase. All the p orbitals are showing in phase combination, that is constructive interference. What is that? This p atomic orbital, and this is C1 atomic orbital, and this is C2 this is C2 orbital. So these they are in next third one C3 and next fourth one C4. So all the above the plane orbit lobes are with positive sign, and all the lobes which are below are with negative sign. So all are going to show in phase combination, that is constructive interference. So here all are showing the bonding interactions. So that is C1 is showing bonding interactions with C2. Again, C2 is showing bonding interactions with C3. And again, C3 is going to show bonding interactions with C4. So here, totally we are going to observe 3 bonding interactions. Okay. So coming to the, as I mentioned before, where there is a node, then only we are going to observe anti-bonding interactions. But within the case of Xi1 energy level, there is no node, hence we are not going to observe any anti-bonding interactions. Coming to the Xi2 energy level, here number of nodes are is equal to 1. So here I was introducing the node in this position. So here C1 and C2. When we observe the lobes of C1 and C2, both are in same manner. That is with positive, they are going to line with same manner. That is this lobe with positive, and this lobe is also with positive, and this lobe with negative, and this one is also with negative. So C1 and C2 are going to show bonding interactions. So whereas coming to the C2 and C3, here this lobe is C2 lobe. Okay, this one with positive, but whereas coming to the C3, this one with negative. So we should mention, we should notice this point where there is a node. Okay, there is zero electron density. Why? Because due to the oppositely charged lobes of p atomic orbitals. Okay, so hence these two are showing anti-bonding interactions. So coming to the C3 and C4, again these lobes are aligned in same manner. So these two are with negative charge and these two lobes are with positive charge. So these two are again showing bonding interactions. So within the case of Xi2 energy level, total bonding interactions we are going to observe are 2 and 1 anti-bonding interactions. Okay. Next, moving on to the Xi3 energy level, here number of nodes are equal to 2. So here are the position of nodes here I introduced here. So coming to the this energy level, this p orbital, when we observe this p atomic orbital, so this one with negative sign and the C2 lobe with positive sign. Due to the passage of the node, these are with oppositely charged. Hence, we are going to observe here anti-bonding interactions. Within the case of C1 and C2, we are going to observe anti-bonding interactions. So coming to the next one, C2 and C3, again the lobes are going to line up in same manner, that one with positive, positive and negative, negative. Here, within this case, these two are showing bonding interactions. Okay, and next moving on to the C3 and C4, they again due to the passage of the node, these two orbitals are going to show anti-bonding interaction. So within the case of Xi3 energy level, totally we are going to observe two bonding interactions, sorry, one bonding interaction, that is between C2 and C3. And anti-bonding interactions are two, that is between C1, C2 and C3 and C4. And next moving on to the Xi4 energy level, we are number of nodes are equal to 3. So the totally 3 nodes are going to be seen here. So the 3 nodes I have introduced like this. So each and every p orbital is separated by one node. So totally here we are going to observe out phase combination, purely out phase. There is no probability of finding the position of electron, and here we are going to see destructive interference, hence the combination is out phase combination. So I will, and next coming to the distribution of electrons within these bonding and anti-bonding molecular orbitals. So p atomic orbitals are totally having, so p orbitals are associated with and one electron each. Now these electrons are going to be introduced within these bonding and anti-bonding molecular orbitals. Now these two electrons are going to fill first with Xi1 energy level and next to the Xi2 energy level. Total 4 electrons are filled within this bonding molecular orbitals. If one more electron is there, then some more electrons are there, they may enter into the anti-bonding level. But here there are only 4 electrons. Those 4 electrons are distributed within these energy levels according to the Pauli's, Haber's and Hund's rule. Okay, now coming to this here, this Xi2 is filled with 2 electrons. Hence, it is known as HOMO. HOMO in the sense highest occupied molecular orbital. Moving on to the Xi3 energy level. So here, when we see the here this position, there are no electrons. So this is the lowest, and with respect to the Xi4, this is the lowest one. So this is the lowest. Here, due to the absence of electrons, this is known unoccupied molecular orbital. In short, it is known as LUMO. So I think so I was clear with this one, with this picture. Moving on to the next one, just reminding within the theoretical matter. So relative energies of these orbitals can be accounted for the counting the number of bonding and anti-bonding interactions in each. Again, here, as I mentioned you earlier within the picture, those I have mentioned here. So within the case of pi 1 in the sense Xi1 energy level has bonding interactions between C1, C2, C2 and C3, and C3 and C4. Total 3 bonding interactions. And anti-bonding interactions are 0 because here number of nodes are 0. Moving on to the Xy2 energy level, number of nodes are 1. Due to this, we are going to observe 1 anti-bonding interactions. And total bonding interactions are 2. That is between C1 and C2 and C3 and C4. And next, moving on to the pi3 energy level, here number of nodes are 2. So we are going to observe 2 anti-bonding interactions and 1 bonding interaction, that is between C2 and C3. And next, moving on to the Xy4 energy level, it is having 3 nodes. So each and every p orbital is separated by a node. Hence, we are going to observe 3 anti-bonding interactions and bonding interactions are 0. Next, moving on to the pi molecular orbitals of benzene. So, pi molecular orbitals of benzene. As we all know, the benzene is having this cyclic structure. So, when we see the structure of the benzene, it is associated with, it is also known as aromatic compound. When we see the structure, it is having 3 double bonds within its ring, and when we observe those double bonds also, those are in conjugation. Okay, one double bond, again single bond, again double bond, again single bond, again double bond, like that. So, and one more thing here, these double bonds are not going to be fixed in their positions, they are going to be move on within the carbon, within the ring. So that is known as delocalization. So due to the delocalization of those double bonds, those pi electrons are going to be move on within the cyclic structure. So which shows the resonance. That resonance is going to increase the stability of the benzene molecule. And next, coming to the important point, each molecular of orbital of benzene consists of a combination of 6p orbitals, totally 6 carbon atoms. So 6p orbitals. Okay, so these 6p orbitals are associated with 1 electron each. Okay, so the total 6p orbitals are purely sp2 hybridized due to the presence of conjugated double bonds. And once again, I am reminding you, so benzene is highly stable because of its resonance double bonds, which increases the stability of the molecule. And coming to, these are the 5 molecular orbitals of benzene. So coming to this is the increasing energy level. As I mentioned you earlier, the same is it in the case of butadiene also. Here also, within the case of 5 molecular orbitals of benzene, the same process is going to be repeated here, but it is a cyclic structure. Only that is the difference here. Here, now, this is the increasing energy. And next, the 6p orbitals, which are having 1 electron each. So those are overlapping each other and results in the formation of molecular orbitals of benzene. So this is the center horizontal line, and this line is known as non-bonding line. Here we are not going to observe any vibrations. No overlapping is seen here. And the orbitals which are lying below this line are known as bonding molecular orbitals. These 3 comes under bonding molecular orbitals. Next, moving on to the above the line, above the non-bonding line, these 3 orbitals are known as anti-bonding molecular orbitals. So coming to the first one, next we need to introduce the nodes. So within the case of first energy level, number of nodes is equal to 0, and next energy level nodes are 1, and next one 2 nodes, and next one lastly 3 nodes. So moving on to the first one, number of nodes is equal to 0. That indicates within the case of Xy1 energy level, so as it is a cyclic structure, we should see clearly the lobes above the plane and below the plane. Okay, so here above the plane all the lobes are with positive charge, and below the plane all the lobes are again with negative charge, like this. Okay, so hence these, I will show you clearly, 1 minute. So these are lobes which are lying above the plane. So, and these are the lobes which are lying below the plane. So above the plane, all the lobes are showing bonding interactions. Okay, so these lobes are showing the bonding interactions, and below the plane all the lobes are showing the bonding interaction. So totally here the combination is in phase combination, that is within the case of pi 1, that is xi1 energy level. When we observe the structure, here all the lobes are assigned with positive. Okay, and below the plane again the lobes are with negative charge. So completely this C1 is showing bonding interactions with C2, and again C2 is showing bonding interactions with C3, and again C3 is showing bonding interactions with C4, C4 is showing bonding interactions with C5, C5 is showing bonding interactions with C6. Hence totally the combination is in phase combination. So here total bonding interactions are 6 bonding interactions, and anti-bonding interactions are purely 0, because here number of nodes are 0. And next, moving on to the next energy level, here we can see pi 2 and pi 3. These two are belongs to the same energy level as they are having the equal energy. So within this, within this energy level, number of nodes are equal to 1. So here, with the coming to the pi 2 orbital. So within the case of pi 2 orbital, I was introducing the node. That node is passing through the bond, cutting the bonds. Okay. So due to this, what happens here when we observe the orbitals? So this is C1 and this is C2. These two orbitals are lined up in same manner. So this slope with positive and this slope with positive, and again this one with negative and this one with negative. So these two are showing bonding interactions. So coming to the C2 and C3, this one with positive and this one with negative due to the node passes. So these two are showing anti-bonding interactions. So coming to the C3 and C4, there is no node here. So again these are lined in same manner, for negative, negative, positive, positive. Hence these are showing bonding interaction. Similarly these two. But coming to here again, due to the presence of node, C4 and C5 and C6 are showing anti-bonding interactions. Okay. So moving on to the Xi 3 pi 3 energy level, here the node is passing through the atom. So within this case, there is two possibility of passage of the node. One node can pass through the bond, and one node it can pass through the atom. So here I have shown the node is passing through the atom. So where there is a node, here also the orbital exists. But to clear for my convenience to explain it clearly, so here I was not representing the p orbital, but the p orbital exists. So coming to here, so these are the two p orbitals aligned in same manner. So these two are showing bonding interactions. So this is above the plane, and again observe below the plane. Okay, so these two are with same line up in same manner, that is positive and positive and negative and negative. So this is below the plane. So again these two are showing the bonding interaction, but whereas to here, so this one and this one above the plane, this one and this slope with positive and this slope with positive. Okay, they can show bonding interactions. Okay, but whereas this slope and this slope, they are going to show anti-bonding interactions. So moving on to the next one, Xi4 energy level. Here, within the case of Xi4 energy level, number of nodes are is equal to 2. So there is here the two nodes are passing through the bond. So here I have represented the nodes. So due to the passage of the node between C1 and C2, here lobes are oppositely charged. Hence here it is going to show antibonding interactions. Whereas C2 and C3, here there is no node. Hence the lobes are lined in same manner. Okay, positive, negative, negative, positive and positive. So these two are showing the bonding interaction. Similarly, here also C5 and C6 are showing the bonding interactions. Whereas coming to here, these three and these three are showing the anti-bonding interactions due to the node passes. And moving on to the next one, Xi5 energy level. So one node is passing through the atom and one node passing through the bond. So now these, when we observe these orbitals, here this p orbital, so within the structure clearly above the plane and below the plane, so this lobe with positive charge and above the plane this lobe with negative charge. So due to the passage of the node, these two are showing anti-bonding interaction. Similarly, this lobe with positive negative charge and this lobe with positive charge, this due to the passage of the node, these two are showing anti-bonding interactions. Again here, this one with above the plane, this one with positive charge, and above the plane this one with negative charge. So these two are showing again anti-bonding interactions due to the passage of the node. So again below the plane, when we observe, these two are in lined up in same manner, hence these two are showing the bonding interaction. So within the case of 5 energy level, we can see two bonding interactions and two anti-bonding interactions. Coming to the next energy level, here number of nodes are 3 totally. So within the case of 5-6 energy level, totally we need to represent 3 nodes within the structure. So each and every p orbital is separated by a node. Here we can see clearly. So each and every p orbital is not showing bonding interactions. Here the phase is completely out phase combination. So here bonding interactions are 0 and anti-bonding interactions are 6. Now we should go for the filling of the electrons. So now each p atomic orbital is associated with one electron. Now those electrons are going to be first filled up in the bonding molecular orbitals. So these bonding molecular orbitals are filled completely. Hence these are coming to the bonding molecular orbitals compared to the pi 1. Pi 2 and pi 3 are the highest energy levels, which are filled with completely with electrons. So these are known as highest occupied molecular orbital. Whereas moving on to the next one, anti-bonding molecular orbitals, compared to Xi6, Xi4 and Xi5 belongs to the lowest energy level, and here we are not going to see any electrons presence here. Hence these are it is known as LUMO, and that means lowest unoccupied molecular orbital. So this is the thing with benzene. Next, we have to mention one more point. Whenever we are going to observe paired electrons, that indicates the molecule is diamagnetic molecule. So whenever we are going to observe paired electrons, then the molecule is showing diamagnetic behavior. Whenever we are going to see within the orbitals any single unpaired electron, it is going to exhibit paramagnetic behavior. But within the case of benzene and butadiene, here the molecules are completely filled with paired electrons. Hence these two molecules comes under diamagnetic molecules. Okay, thank you everyone.